Hi, and welcome back. Today we're going to look at Chapter 5, beginning of Chapter 5, Section 1, which is on exponential functions. So exponential functions and logarithms are used in a variety of important applications. So we're going to see in this chapter, one, how to use these two functions, and then we'll look at some of those applications. So for today, we're going to be looking at exponential functions, and then we'll also look at logarithmic functions coming up. So we have in exponential functions a new irrational number. Well, you guys have seen it before, but I say new because it deals with exponential functions. Just like pi is used when we're talking about circles a lot, that's an irrational number. Well, the irrational number e is important for exponential functions. Okay, it is a number. We'll talk about that in a minute, but it plays a real important part in a lot of the applications that we're going to be using. Okay, so just please remember e is an irrational number. It's not a variable. Okay, so today we're going to define exponential functions. We're going to talk about the characteristics of it, and then we're going to apply it and solve some problems. Okay, so first definition is that a function of the form f of x equals c times b to the rx, where b is a positive real number not equal to 1, and c and r are real constants. That's called an exponential function with base b. So I want you to notice for exponential functions, the variable x is now in the exponent. Polynomial functions and rational functions, all the other functions we've been doing so far, x, the variable, has been in the base part. So exponential functions are the only functions where you'll see the variable up in the exponent. Okay, that's what makes them exponential in nature. All right, number 2 says an exponential function of the form f of x equals c times b to the rx has the following properties. Good news is the domain is all real numbers. There are no restrictions when you plug in x. You can solve any exponential function for any value of x. So that's nice. That's your domain. The range, however, always goes from 0 to infinity. The y-intercept is always 0, c, whatever that number is. The x-axis, the line y equals 0, is the horizontal asymptote, and the function is continuous. Okay, so those are just some properties of exponential functions. Now we've got our two basic ones written here in parts f and g. If the base is greater than 1, then the slope is going to be positive. C is 1 and R is 1. So we're kind of just doing the basic one here. The slope is positive and y is increasing and concave upward. So as long as this base is bigger than 1, your function's always going to look pretty similar to this curve. Never crosses the y-axis. That's your asymptote. We call these exponential growth problems. The numbers get bigger, the y numbers get bigger as x gets bigger. Now, if b is between 0 and 1, so less than 1 but greater than 0, like 1/2, that's the base, then the graph turns the other way and it decreases because the slope would be negative. Okay? These are called exponential decay problems. Okay? Both exponential. This is growth, this is decay. Okay? So those are just the common looks for exponential functions. Number 3 is our formula for compounding interest. Okay, the principal, P, that you invest at an annual rate, R, in decimal form. So we'll talk about that when we get to the problems. Compounded n times per year for t years. So all of these letters have numbers that are going to go into them. We can figure out the future amount, A. So this is the future amount. If you put this much money in, this is your principal, the starting amount. This is your interest rate written as a decimal. N is the number of times compounded. So you see n's in here twice. And t is the time, always in years. So we're going to use that in just a minute. Then we have that irrational number e in number 4. It becomes a number because it's a limit of this actual function where n is 1. Okay, so if you look at this, 1 plus 1 over x to the x, so we're just using 1 here for the exponent or the same number. Okay, So if we take the limit of that as x goes to negative infinity, we get closer and closer to this number, 2.718. That's rounded, okay? Just like pi, we say 3.14, but that's not the entire number. This is rounded. It's approximately that, and we call that e, okay? E is the value that we're going to use. A special exponential function of base e is kind of used a lot. So we can write y equals e to the rx. Remember that e is 2.718. That's not the variable. X is your variable. Okay? All right. So keep that in mind when we get to the problems. And there is an E button on your calculator. I'll show you that if you don't know where that is. Okay, last one is our formula for compounding continuous. So compound continuous interest is this formula. A lot of you learned that as PERT. Looks like the word PERT. So A equals P, principal, times E to the rate, interest rate, times time. Okay, again, this is the initial amount. This is the new amount you're going to get after so much time. Okay. All right, so let's look at some of these problems. By the way, looking at your calculator, you got two places to find E. One of them is the second function for your division side. That just gives you E, okay? You can also do the second function for ln. That gives you E raised to whatever power you want to put in. So if you know you're going to be raising E to a power, you can use this button, or you can do second divided by and then just do the caret for raising. So either one's fine, okay? Just depends on when you're using it. Okay, so let's look at some problems. So number one says if $9,000 is invested at 10% compounded quarterly, how much will the investment be worth in 9 years? And we're always going to round these answers to 2 decimal places because we're talking about money, okay? All right, so since we're compounding a certain number of times quarterly is 4 times a year, so that means n is going to be 4, okay? There are 4 quarters, so that's your n. How much will the investment be worth in 9 years? All right, and we also got to look at our percentage. 10%. How do you write that as a decimal? As a decimal, it would be 0.10. So we need to know our rate, that's R. We need to know the number of times compounded, and then we need to know the time. Okay, so that's T. All right, so our formula, oh, and then we have our initial amount, the principal, how much we're investing. So here's our formula. Okay, we're just going to plug in those numbers and plug that into our calculator. So we're looking for A, how much this is going to be worth in 9 years. Principal is 9,000. 1 plus the rate, 0.10, over the number of times compounded, 4, and then to the number of times compounded times how many years. Okay? Now, the nice thing about this, if you have a graphing calculator, which hopefully you do, if you don't, I would do this first, raise it to this power, then multiply by 9,000. So again, if you don't have a graphing calculator, do what's in here first, get that number. Then take that number, raise it to the 36th power, and then multiply by 9,000. That's the order that you would have to do that, order of operations. If you have a graphing calculator, we just put it in exactly like it looks here. 9,000, parentheses, 1 plus 0.10 divided by 4, close your parentheses, raise it to the, you can either put 4 times 9 or you can put in 36, doesn't matter. Okay. All right, that will give you $21,892. And we're going to round to the nearest cent, so that would be 82 cents because that's 7. Okay, so there's our answer. 21,892 times 82.82. Okay. Okay. All right, so just using these formulas. Number 2, If $15,000 is invested at 7.1% compounded weekly, how much will the investment be worth in 25 years? All right, so let's find our P, principal. Our interest rate, write that as a decimal. So that would be 0.071, that's the rate. Compounded weekly, how many weeks in a year? 52, so that means N is 52, okay? That's what we'll be doing here. And then this is our time, 25 years. Okay, so we're still looking for A, still using that same formula. Plug in those numbers. So to find how much we're going to have after 25 years, we're going to start with $15,000. 1 plus the rate, 0.071 over 52, and then 52 times 25. Okay, so you just make sure you know these numbers before you plug them into the formula. All right, so this one we're going to do 15,000 times 1 plus 0.071 divided by 52, close your parentheses, and then raise it to the 52 times 25th power. Now, if you guys have the really old calculators and you don't get the exponent, put parentheses around that, okay? Put parentheses around those. So that gives us 88,000. Oh, I'm talk about rounding, $88,397.13 because that's a 1, right? All right, so 88,397.13. Okay, so this is compounding a certain amount of time every year. Okay. All right, number 3, this time it says compound continuously. So that's our clue that we are no longer using that first formula, but we're going to use this formula. This is the formula for compounding continuously because we don't have a number of times per year we can use. We don't know, continuous is all the time. So there's no N in this problem. Okay, so this is what we're going to use. So we're going to start with P, 5,300. Here's our interest rate, 0.062. That's going to be R. Always write it as a percentage. And then this is our time, 24 years is T. All right, so we're looking for A. We're going to start with $5,300. E to the rate, 0.062 times 24. Okay. Again, you can put that in your calculator, just as that is. So you can use either E button. Now, since I'm raising E to a power, I'm going to do second ln. Okay, I want the power there. So I'm going to do 5,300 and then do second ln, and that'll give you the power already. So now all I have to put in is 0.062 times 24. Okay. So if you did it the other way, 5,300, and you just did second divided by, then you have to put in the little caret. You got to raise it to, that's the only difference, okay? So either way is okay. So we're going to get $23,469.62. Okay. 23,469.62. Okay. All right, next one. Mary has recently inherited $11,000, which she wants to deposit into a CD account. She has determined that her 2 best bets are an account that compounds quarterly at 4% and an account that compounds semi-annually at 5%. Which account pays more interest? And how much will the balance be in that account after 3 years? Okay, so we got account 1 over here, account 2 over here. Let's see which one gives us the most. So we know we're starting with $11,000. That's the principal for both. Okay. Now, account 1 is quarterly 4%. Quarterly is 4 times a year. So that's your N value. 4% is the rate. So that's 0.04. And both of these we're trying to figure out 3 years. So both have the same time, both have the same principal. All right, so we're going to start with the first account. Okay, there's our formula. So we have principal, which is 11,000. 1 plus her rate was 4%, 0.04, 4 times a year, every quarter. So it would be to the 4, you always take that same number times the year, so 4 times 3. We'll do that in just a second. Let's go ahead and set up account number 2. So account number 2, same formula. Okay, account number 2 is semi-annually 5%. So how many times is semi-annually? Semi means twice, right? So semi-annually is twice a year, and this rate is 0.05. Oops, I'll put the 0 there. Okay, 0.05 instead of 0.04. All right, so we have principal, still 11,000. 1 plus the rate, 0.05. This time we're dividing by 2 times semi-annually, and this time 2 times 3. Whatever this denominator is, that's what you use times the time up there. All right, so let's put those in our calculator, and let's see what we get. Let's slide this over. All right. So the first account, clear that out, is 11,000. 1 plus 0.04 divided by 4. Close your parentheses. Raise that. I'm just going to go ahead and put 12. 4 times 3 is 12. So that gives us 12,395 and 8 cents, right? We're going to round up. So that's 8 cents. All right. The second one is 11,000. 1 plus 0.05 divided by 2. And we're going to raise that to the 6th power, right? So that gives us 12,756 and 63 cents. Okay. So all right, so now we can answer the question, which account will pay the most interest and how much will the balance be in that account? So that would be account 2 pays the most interest because we got more money, and this would be the total. Okay, if they asked you for the difference or the interest, what if I asked you how much interest? You would just take this minus that, right? If I take that amount minus the 11,000, didn't ask me that, but so $1,756.63 is her interest, right? The extra amount. Okay, so if you're asked for the interest, just subtract those two. All right. Let's look at number 5. Find the amount of money that will be accumulated in a savings account if $10,000 is invested at 4.9% for 15 years, compounded continuously. So again, there's our word. That means we're going to be using this. Okay, it's the only time you use PERT is compounding continuously. So we're taking $10,000. That's the principal. The rate, 4.9% is 0.049. So there's your rate, 0.049. And the time, 15 years. So we just put that in our calculator. Clear that stuff out. So we're going to do 10,000 E, second ln, 0.049 times 15. Just like that. So 20,854 round 82 cents. Okay. So 20,854 82. Please be careful in hogs. Got to round correctly to get that problem right. So just pay attention to those numbers. Okay, number 6. Jeff's father is planning to open a savings account to pay for Jeff's college education. He found a bank that will pay 8% interest compounded daily. How much will he need to deposit initially so that in 9 years the balance will be $165,000? All right, so this one's a little different. It's not continuous, it's daily. Daily means N is 365 days in a year, so N would be 365. We have his interest rate, 0.08. All right. Now, we have the time, 9 years. But what we were given is how much he will have after the 9 years. This is asking how much will he need to initially deposit. That's P. So we're looking for P. This is A. Okay, this is how much will be in the account. So this problem looks like this. We got to find the initial amount. So the rate is 0.08. N is 365. 365 times 9 years. Okay, so read that carefully. How much will he need to deposit initially so that in 9 years the balance will be $165,000? That's the new amount, future amount. Okay? All right, so all we have to do here, that's a little different. We're going to solve for P. So we're not going to put P in the calculator. We're just going to put all of this in the calculator. Okay? So leave this out for now. So we're just going to put in parentheses 1 plus 0.08 divided by 365 raised to the 365 times 9 power. All right, so that gives you 2.054271138. Do not round that in your calculator. Leave that right there, okay? I'm going to go at 5 places. So I've got 165,000 equals, no, I can't see that over there. Put it over here for you. So that's 2.054. You don't want to round too much. If you round too much, you're going to get the wrong answer in box. So I'm going to go out at least 5 places. Leave that in your calculator though. So we get 2.0547p, right? This times p. I'm just going to put the p at the back. It's just like a 3x, right? So to solve for p, we're just going to divide both sides by this number. Now, when you do that in your calculator, we're not going to round. So I'll show you how to do that. Okay. So most of you that have the new calculators, we're going to put in 165,000 divided by, and then just arrow up to your answer and hit enter. That copies and pastes it so that you don't round anything. You're going to use the whole number and get the right answer. So $80,320.46. It's real important because Hawks won't like you if you're off by a penny. And I don't want you to have to keep redoing these problems. Okay? So 46 cents. I'm telling you now, if you round, you're going to get the wrong answers. So just use copy and paste, or at least go 4, 5, 6 places out if you don't have the capability to do that. Okay? All right. So that's how much you have to put in the account now, so that in 9 years, that's how much you'll be in. Okay? All right, last page, number 7. Now we're on to other things, not money related. So typically, you're going to be given the formula for that right now. So number 7, we have this formula. Okay, it says in a certain environment, a colony of bacteria grows according to this model. So you're just going to be given the function, and you're just going to plug in the right numbers in the right place. So A of t is the number of bacteria present at time t, which is in hours, after the culture is taken, and A sub 0 is the initial number of bacteria present. All right. If 200 bacteria are initially present, so this is A sub 0. Okay, how many bacteria are present? That's A sub t. After 10 hours, that's obviously the time, right? So a sub t equals 200 e to the 0.19 times 10. Actually, this is a sub 10. Right? We're putting 10 in for t. So that's what that is. Okay. So t is 10. So we're finding a after 10 hours. So that's the function. We're just going to put that in our calculator. So 200 e second ln 0.19 times 10. So after 10 hours, we're going to get 1,337, and it says round to the nearest whole number this time. So we're going to just look at that 1. So we're going to keep it at 1337. So a sub 10 is 1337. Nearest whole number, it said. Pay attention to what you're rounding. Okay? All right, and the last one. Concentration, C of T, of a certain medication in the bloodstream measured after T minutes is given by this formula. C of T equals 0.07 times 1 minus E to the negative 0.3 T. What is the concentration of medication in the bloodstream after 3 minutes? So there's your T, and that's the only variable you need in here. So we're going to find C after 3 minutes. So we're going to plug in 3 for t. So 0.07, 1 minus e to the negative 0.3 times 3. Okay, that's the exponent. So just be careful how you put this in your calculator. Okay? All right, so we're going to do 0.07 parentheses 1 minus e, second ln. Okay, and now we've got negative 0.3 times 3. You can make that 0.9 if negative 0.9. Now, before you put the parentheses, we don't want the parentheses up here. We want it down with this one, right? So hit your right arrow. That'll get you down to the base, and then close your parentheses. Okay? Otherwise, you'll get an error message. So if you want, just make that negative 0.9. You don't have to worry about it. All right. So that gives us 0.04. What are we rounding to? 3 decimal places. So 0.41, but since that's a 5, that's going to become a 2. So 0.042 will be our answer. So that is C sub 3. Okay? All right. So that does it for these types of problems, at least in this first section. So work on those. Be careful with how you put it in your calculator. Be careful how you enter things in Hawks. Read what you have to round to. And let me know if you need any help. See you back here soon.